This video will demonstrate the DTI901 UHF RFID read-write head from IFM. I'll be integrating this into an IO-Link IFM master and also into an Allen Bradley PLC using an add-on instruction. The tags I'll be reading in this video is the E80414. This has three different memory banks, the EPC, the TID, and also the user memory. In the Allen Bradley PLC, there's been an add-on instruction written for it, and this is specifically written for single tag applications. It is also meant to be used in the single EPC, auto read, and auto write modes. There are several different modes within the DTI, but this one will focus on those three modes and single tag applications. By default, you'll see the single EPC mode is enabled. This is the default setting of the DTI901 and also of the add-on instruction. What it will do is when a tag is present in front of the reader, we'll see that the tag present bit goes high and will also read the EPC data. That includes the length, the RSSI value, and also the data on the tag. If we monitor the single EPC buffer, we will see that this is a 16-word array, and that is the max array that you'll get in the EPC code in the single read EPC buffer. To configure the DTI to function in your application, you can also set different settings within the DTI. That is the settings towards the top, and these are user input settings. We'll look at the power read and the power write. This is a value from 10 to 23, and it is going to adjust the field of view in front of the reader. Any of the input value ranges for any of the settings here can be referenced by clicking on the three dots in the add-on instruction and looking for the tag. The descriptions have all been imported so that we can see what the user settings are. So here we can see the output power inventory, and for the reading range is 10 to 23. And we can see all the different tags input here as well. For my application, I'm going to tone this down so I'm not reading the information so high. So we'll set it to a 12 and a little more power for the write to 14. The RSSI value is the power reading from the tag, so how close or what the strength of the reading coming from the tag. We can see that the tag in front of it is coming in at minus 23. As I pull the tag further away from the reader, you can see that the tag or the RSSI value is growing in greater negative number. This can be useful if I do have an application where multiple tags may be in the reading area, but I only want to read a tag in a certain window. I can have a large reading area, but a window of RSSI values, so I am only still going to detect one tag, even though multiple tags are present in front of the reader. For my demonstration here, I'm going to leave this from minus 128 to 0, and that is the range of these values here as well. The detection mode is the behavior of the DTI in the application and the quickness of the read. All of this information is also held inside of the manuals. So if we go to the DTI901, we can go to the download section and see the operating instructions. In the operating instructions, you'll see a lot of the same language that's used in the add-on instruction. So here's the detection mode, and we can see the different settings that are possible here, and the description, so you can determine what is best for your application. Now, for the settings inside the add-on instruction, what values it is, we can click on the three dots like I showed before, but you can also use the IODD PDF. This can also be found under the download section in the PDF IO-Link interface description. Here, if we scroll to the acyclic data, we will see that the same modes of detection can be seen here on page 12. And so here, this is a value of 0, 1, and 2. And these are the descriptions that have been imported into the add-on instruction. So this is the documentation portion, or of course you could also look at it here in the add-on instruction. So for my demonstration, I'm going to leave the detection mode to 0 and go to the data hold time. This is when you're looking at the single EPC, how long the data is going to be held in the buffer after the tag present bit has gone low. Currently, when I remove the tag, as soon as the tag present bit goes low, it holds it for 200 milliseconds by default, and you can see the data goes to 0. What I'm going to do is change this to 2000, and when we set the configuration, it will hold the data in the buffer even though the tag is not present. The select memory bank, the auto read and auto write have to do with the auto read and auto write modes of the DTI. The select memory bank is 1 for EPC, 2 for TID, and 3 for user memory. When I change the antenna mode to auto read or auto write, it's going to reference the memory that's been set in the configuration. So here, since I'm in this demonstration, I want to use the user memory, I'm going to change this to a value of 3. So that when I do change the mode, I am not going to be reading the EPC in the auto read buffer, I'll be reading the user memory data. The max length that you can read and write in the auto modes is 28 bytes. You also can have an offset start address, so if I do have a 64 byte tag, like I do, I have the E80414. We can see that the memory size is 512 bits or 64 bytes. While I can't write the 64 bytes completely using the add-on instruction, I am able to offset the address so that I can read or write starting at a lower address. Now that I have all my configuration set, I'm going to use the configuration command trigger. This is going to set all the tags that have been set inside the add-on instruction. We can monitor the DTI configuration response buffer, and this will echo all the information back so that I can verify from my PLC the values have been set. On the rising edge of the configuration command trigger, we'll have to see the command ready bit to be high. This means I can set the configuration command trigger. Once I do set it, the command ready bit will go low, the commands will go busy as they're processing, and when they're complete, they will go done. So here on the rising edge, they have gone busy, done, and we can see that the information matches the information that I have set inside the add-on instruction. So I know the DTI is correct in my configuration. Now I'm ready to set the antenna mode. So here I am still on the single EPC mode, and we can see that we're reading the data. But now we want to change it to the auto write data. So when I change this to an antenna mode of 1, it's going to move the antenna read mode, and you can see I had the tag present already, so the read write has completed. And now I can see I have information inside my buffer, and it is of 28 bytes long. If I would like to change it, so to demonstrate how the configuration will change it, I will set this to 26 bytes. This will take off the 55 and 66 because I'll no longer be reading 28 bytes, I'll only be reading 26. So the tag is still present. When I change the configuration, the configuration commands are sent, and the auto read command will be sent again because I'm in antenna mode auto read. So my configuration has completed, my data has updated here, and we can see I've lost both 26 and 27 because I'm only reading 26 bytes of data. So I'll go ahead and set it back, and let's write information to the tag. So I have my information back. I'll take the tag away, and here I'm going to set this to an antenna mode of 2. Now I need to set the data that I would like to write. We can see that I'm in auto write mode. As soon as the tag comes present, it's going to auto write the information. What's going to write is what's in the auto write buffer. So here I am in my auto write buffer now, and I have my values here. So again, I'm just going to write the last couple bytes. This time I'll change it to 77 and 88. Once I have the data set, I can now bring the tag present, and we'll see that the auto read write will go done. This means that the tag information has been written, and now I can simply switch back to the auto read mode and verify my information here. So I'll look at my auto read buffer, and here's my 77 and 88. I do not have to pull the tag away. I can stay in the auto write mode. So I'll set my auto write mode and I'll change it to 11 at the top. I can write the data and switch over and read the data without moving the tag. And here we can see that I'll have my 11 here. So whether you take the tag away, whether you leave the tag present, if you want to verify the write and just switch over to the read, you can do that with the add-on instruction. You can monitor the auto read write done bit. Each time the tag goes away, the done bit will go low. Each time you change the mode, the done bit will go low again. So if I switch this to auto write, we'll see that the done mode switches back, and if we switch it back again, we can see the done bit is changing state. So that's how we can use it in our logic. The last thing to demonstrate here would be the data hold time. Here it's 2000 milliseconds. If I switch this back to a 0, when I remove the tag, we will see that the data, here we can monitor the 16 and the 27, and we can also monitor the data here as well. We'll see when I remove the tag, the data is held for 2 seconds before it goes to 0. So that's the data hold time. If I want to read the other memory banks, I can simply switch this to a 1 or a 2. If I want to read the EPC or the TID, I do need to make sure it's not set to 28 bytes. We do want to match the information that's set on the tag. So if it is 16 bytes of data, I would need to set this to 16 bytes. However, we add 4 bytes of data on top of the EPC information. So instead of reading 16, I actually want to read 20 bytes of information. If I set this to a value of 1 and toggle the trigger again, we will see the auto read data is now going to read the EPC data, and we can see that EPC data is going to be in the auto write buffer. Sorry, auto read buffer. If we change the values to hex to view them a little easier, we'll see that we have some header information here. This data can be found in the manual. And we can see the memory bank data and the bits that we add to it. So we're seeing the CRC, the PC, and the XPC bits that are added to it. So if we're going to use that information, we would use it in the auto read mode. If we don't need this information, we can simply use the single EPC mode. So that covers the functions of the auto read and auto write and how you can configure the DTI to work in your application.